Good morning, dear students. Today I want to start the chapter 9, that is array. So you can see in class 11 you have got the introduction part of array. What is array, how to store the values in the array, and how to manipulate the data from the array, how to take the addition, how to find out the greater number from the array. So just little bit explanation I want to give. I want to recall the chapter, whatever you have understood in the last year. Array means it is a kind of variable in which we can store the values, more than one values we can store in the array of same type. Like one example, say you want to store marks for the students of class 12. So for example, you are having in your class 50 students, so you want to store in the variable the 50 marks. So for 50 marks, if you take a simple variable, then you have to take a 50 variables for storing the 50 marks. Am I right? So to minimize writing so many variables, one variable, it is called user defined variable or fundamental derived type variable. We have got all these chapters in the types of variables, so we can use the array variable. So in the array you have to give how to declare the array. Here is one example on your screen. So here is the example. You can see array. Here the value, say how many values are there in the array: 1 2 3 4 5 6 7 8 9 10. So 10 values are there, so the size of the array will be 10. So here the n elements, given an array of n elements, you can see here, so here will be n. So now, so this is how the data you will store, and how to store the data by using the looping. I think all this you have understood in last year. So let us come to our topic, which is there in your book. Page number 427, which we are going to discuss. Page number 427, operations on data structure. That means more elaborately of array. In practical life, what we are going to do with the array. So these are sub points, the basic operations we will do that are performed on data structure. So number 1, insertion, deletion, searching, traversal, sorting and merging. So insertion means what? Say there are 10 students marks I have entered. Now one data is missed, so 11 students are there, so I want to add another data in the array, so that is insertion. So inserting the data, how we will do. So next is deletion. Say I want to delete extra data, it is being entered, so I want to delete it, so that is deletion. Searching means among the data I want to search the person who has got full marks, that means say 50 out of 50, so I want to search that number. So for searching, this operation also we can do with the array. And then traversal of a data structure means processing all the data elements of it, that means to process the data one by one. Next is sorting. Sorting means we will arrange the data in particular order. That sorting we have already done, I think, in class 11. Then merging, that means merging means what? Say in one array there is 5 elements and in another array there is 6 elements. Now I want to merge in single element. Say there will be another array variable where I will merge that both the 5 and 6 elements, and it will be 11. So that is called merging. So these operations, 6 operations we will do. We will learn how to write the algorithm, and we will learn how to write the program. Now let me tell you, the students, in this chapter you have to learn how to write the algorithm, because in the final exam, in your question paper, you will get mostly to write the algorithm or the part of the program. No need to write the full program. They will ask which part you have to write, that part you have to write. So algorithm is very much important. It is given on your book. So when I will go through explanation, I will tell you which algorithm belongs to what and in which chapter it belongs. So let us start the topic. Page number, you can come to the topic 430 on your book. 430. Linear search means searching are of two types. One is linear search and another is binary search. You can see in page number 431. So what is linear search? Now let us see one diagram here. See the linear search here. Say your data element is stored in the array A0. In A0, say A is the variable and the array subscripted value is 8. The size is 8. So in A0 the value is stored 10. In A1 value is stored 50. In A2 30. So like that it will go on. Now this, among this data, the people want to search or user want to search the value 20, whether 20 is there in the array. If it is there, then in which location. So this is how we will search. Now what is linear search? Linear search means the data will be placed haphazard way. You can see here 10, then 50, then 30, then 70, like that. And in the linear search, what it will do? It will search one by one. That means first it will search A0. If the data, that means say we are searching the value 20. So whether the 20 is there in A0, if yes, then it will show you. If no, then it will go for the next search. In A1, it will see whether A1 is the value 20. No, then it will go on continuing. So in which location it will get? Say it is there in the A6 position. So after this, if it is there, it will match. If condition we will use for that. So if it is match A6 is equal to 20, yes, then it will show you search is successful and the position of the value is in A6. So this is how it will search the value. So you can see what is the algorithm, how the algorithm is being written in the page number 430. Page number 430. So here they have explained. See here one example, it is given input array, value is inputted, x equal to 110. That is what the search element they have given 110. Now 110 is in which location? You can see 1, 2, 3, 4, 5, 6, 7. So if I start from 0, 0, 1, 2, 3, 4, 5, 6. So it is in 6th position. So element x is present at index 6. So input the value x equal to 7. X equal to, they have given 175. That is, they want to search the value 175. If it is not there, the output will be -1. That means the value is not present. So this is how the internally it will go on. Now here a simple approach is to do linear search. How to do? This is the steps they have told. Already I have explained that. Now this is one example they have written to search the element. Now here one example. Now let me tell you guys, the students, sorry, here just I have not shown here on my screen the algorithm, because on the net I am not getting the proper algorithm, the easiest one. So I have compared all, and I am having the conclusion that the algorithm for the array, linear search, it is better on your book 430 page, linear search in array. You can see the algorithm written, no, algorithm linear search in array, that you copy it. Now let me explain the linear search here, then I will go for the program which is there in the screen. Just look at the book, all of you. Step 1, set CTR equal to L. L means what? Lower bound. Lower bound means what? Where from the data I will start counting. So in the program you can see here, let us go here again. Here you can see data is started from A0, array ARR 0. So 0 is the lower bound. Okay. So here also in your book it is given, you see in the comment, lower bound is 0. So the L is stored as 0. 0 is storing in CTR. Now search for the item. Repeat the step 3 through 4 until C is greater than U. CTR is greater than U. That is what? The searching value, that is it is 0, is greater than U, that is upper bound, that means last value. If there are 10 values, then the last value is 10. So here you see, if ARCTR is equal to item, that item which you want to search, you will store there item. Print if it is equal, that means it is you have searched, so search successful. Where is the location? That is the location. Print CTR is the location of item, break, and then the process will be continued until you will get the item, or until you have finished searching the last value, that means last array variable. So here if CTR is greater than U, that means what? That means upper bound, the array variable upper bound is greater than your searching, that means your searching is finished. So after searching you are not getting the item, that means search unsuccessful, that means there is no item in the list. So this is how the algorithm. So they will ask you in the in question algorithm. If they will ask, then you have to write the algorithm. If they will tell that write the program, simple program for linear searching, you have to write the program for linear searching. Now come to the screen, the program. Let us go. So here int search, one function they have created, int ARR, int n, int x, these are the argument. N means total number of values, and x means the item. So int I, for I is equal to 0, I less than is equal to n. N means last value, and I plus plus. If ARI is equal to x, x means item, that value which you want to search. If it is equal, that is return I, it will return. And if it is else, what? Else not given, that means if it is not true, then it will return -1. That means if the number is not there in the list, that means it will return -1. So let us go to the main program here. Int main ARR, the values it is given 2, 3, 4, 10, 40. Now the item which you want to search, that is x equal to 10. Now int n is equal to size of the array. Size of the array is stored in n. Okay, so size of array 0, that means here divided by, that means here this line, just to avoid this line, because no need to write this line, instead of that you can write, you can follow your book, in your book what the program it is given. So or else you can write that one also. That means size of ARR, that means last value divided by size of the first value, that means is equal to last value, that means the last value. Here you can give n is equal to how many values are there, 3 4 5, that means n is equal to 5 you can give. Now here the main portion, just you come, int result is equal to search ARR and x, result is equal to 1, see out element is not present in array. Just let me scroll here, in an array. And another is, here they have used the conditional operator. As you know how to use the conditional operator, instead of if condition they have used the conditional operator. If result is equal to -1, that means -1 means what? That means you are not getting this item in your list. That means what it will print, element is not present in an array. Else, you can see else part, it is after colon you have to write else. That means if the search, this search function will search the array value on the list. If they the value from here it is that means you have got the value in some item, in some that is on the list you have got the item, then the result will become I. Here you can see I. So then element is present at the index. Here you see the result. Result means whatever the result it will store from here. That means I want to enlarge it and I want to show you. You can see here, if array I is equal to x, then return I or else return -1. So here let us go back. So that return I will store in result. So result, so it will come here. Now this is the whole program, very small program, very simple. Now let us execute the program. You can see here the output element is present at index 3. They have shown you the output. So let us go back to the output, the program. See, they have given 10, no, 10. So if we count, if we start counting this value, it is stored in ARR 0, ARR 1, ARR 2 and ARR 3. So what is the position of the value which is been found? It is in 3. So element is present at index 3. So this is how the program works in linear search. So you can copy the program. Just let me set nicely so that you can copy it. Just start writing. Now let us see the binary search. So before go for the binary search, just you look at your book. What is binary search? Binary search is also a kind of searching where we need to search when the data is already being sorted. So because when there is a, that means very large amount of data, so at that time to search with the linear search, with the help of linear search, it becomes very slow process. Okay, so linear, because in the linear search the data is being stored haphazard way, and one by one it will go on searching. Say if there are thousands of values are there, that means it will start from beginning from A0 to 1000. So if there is a last item, so it will go searching up to 1000. So the process will become slow. So that's why to make it fast, another process they have introduced, that is binary search. So in the binary search, one condition is that means the item should be sorted either in ascending order or descending order. So if it is ascending order, then the algorithm is different. If it is descending order, then the algorithm is different. So that algorithm you can see. Now let me show you first the picture of the binary search, what it is going to do, so that you can understand. Search 23. So I want to search 23 from the list. So what I will do first? So first of all, the thing is that your first work will be, you have to arrange the data in sorted way. Can you see it is there placed as sorted way? 2, then 5, then 8, then 12. That means first you have to sort the values. So you have, for that you have to know the sorting program. So sorting program I will go for the next video. Now after sorting, what you will do, you will take the middle part, that means middle value. So first of all, the mid value, what you will do, say if there are 9 values, 0 to 9, how many values? 10 values. That means fifth one is the mid value. See here, lower bound, higher bound and middle bound. Okay, so if it is 0, that means middle bound is 4. So now this one, what is the value stored, we have to first decide whether which value we are searching, it is greater than this value or less than this value. So first of all, whether 23 is greater than 16. So if it is yes, that means we will not search from here, we will not start the searching from here. Where from we will search? Then at that time the lower bound will become not L equal to 0, the lower bound will become M, that means 4. Lower bound will become L equal to 4. So the searching will be start from here. Okay, that means not here, that means it is greater than this one, it is greater than this one, that means M plus 1. The greater lower bound will be M plus 1. So M plus 1 means 4 plus 1, 5. From here I will start. Now here, then we will start comparing here. Is 23 is greater than 56? Now like that again we have to compare from here to here. Okay, this is the lower bound, this is the upper bound. Now is your search is greater than this one 56, that means what they have shown here, take second half. Okay, now here that means 16 and 91. So among that these values, which one is the mid value again? So we have to find out the mid value again. The process will go on, okay, until we get the value. So the which one is mid value now? M is equal to 7, L is equal to the lower bound is 5 and H is equal to 9. Now then again it will repeat. Now whether the value is less than less than 56 or more than 56, if it is less than, that means lower bound will be that L is equal to 5 and M will be higher bound. Okay, so now L is equal to 5, M h is equal to 6, then the middle value is what? That means middle value is 23. Okay, so like that the middle value, ultimately that value will come in the mid value, and that is your item which is being searched. So this is how the binary search will take place. So let us go for the program now. Before going to the program, let us have a look once on your book. Algorithm, page number 431. Algorithm, binary search in array. So algorithm is given. Set bag is equal to, bag means beginning. Beginning is equal to L and last is equal to U. That means last means upper bound. Now repeat the steps 3 through 6 until bag will be greater than last. That means until the beginning will be greater than last, the process will be go on. Now mid is another variable where int of bag plus last. Say for example your array size is 10. So array size is 10. So if I start from 0, the value contains in the array 10, that means 11 values. So beginning is 0, 0 plus last is 10. So 0 plus 10 is 10 divided by 2. So it is 5. So 5 is the mid value. Why int given? That means if sometimes says 7 it comes. Okay, total value is 7. 7 divided by 2 is 3.5. So 3.5 array size is not there. So it will it will avoid the 0.2 and it will take the value as 3. So mid is equal to here 5 as per my example. So if AR mid is equal to item, then search successful. Otherwise what? If AR mid is less than item, then again big is equal to mid plus 1. So then again the process will go on. So like that. Now descending order, if it is descending order, that means the data is arranged in greater to smaller. That means again the first part of the, that means if AR mid is equal to item, the process is same. That means 1, 2, 3 steps are same in both the case. Come to the fourth step. They will ask if AR mid is equal to item, then again the same step. If AR mid, that means at that time it will be less, not greater. Just the difference in descending order. In the sixth step it is greater, and in the descending order the sixth step will be less than. So and that part last mid minus 1, big this one the same. So the algorithm you have to learn. Now the program, let us see on the screen the program so that I can show you the output. So before that I can that is to a very long time the program is being paused, so you can write it down through your video. The binary search. So I want to show you the output simple because it is there in your book also, the program. You can take that example also. The program, this one is same as, this part is same as the previous one, linear search. Only the function to create for the binary search, this part you have to, if AR mid is equal to X, then return mid, that is we got the value. If AR mid is greater than X, means middle value is greater than X, then what to do? You have to go to the come to the first part, that means what? In the front part. And if it is less than X, that means you go to the back part. So this is how the binary search will work. And the see 2, 3, 4, 10, 40, Where is 10? 10 is in 3 index, so they got the item. So this is how the binary search works. So till today, that means in today class, I want to stop in this topic only, because little bit tough topic, so you need to digest it very well. So here the dear students, 433 page, they have shown you by taking some examples. In example 9.5 you can see how the searching is going on, because you go through this very well, because they will ask you in the question that if the situation is this, in that part, in which position they will get the searching. So this is how very elaborately they have shown you the binary search, and similar to that the linear search also. So for today's class up to this much. Next day, in the next video, I will show you the sorting, inserting and deletion. Sorting, inserting and deletion if possible in one video. Thank you, students.